Hello everyone. Let's talk a little more about block diagrams. In part two, we're going to specifically look at how do you go from a system level single block down to your first iteration of your internal block diagram. So let's get started. So what you can see right here, here's our requirements again from the previous example, and here's our system level top block diagram, single block diagram. I've stretched it out and changed the shape a little bit to make this a little easier. But essentially, at this point, we have to start trying to break the system into pieces. As you recall from our previous video, we have multiple outside the system environmental inputs. The first one was the solar input. The second one was the input based upon the water conditions, so making it waterproof. And then the third and final one was the ability to sense the water depth as well as the temperature with some level of precision. We also have our output, system to outside, user out. In this situation, this is the output from a web page to a user, alerting the user that yes, there's a flood condition, and according to the requirement, that had to happen within 30 minutes of the flood condition actually existing via the measurements. So how do we deal with this? Well, one of the ways that I like to do it is kind of taking a functional approach. I know that I have to have something that can deal, so to speak, with each and every one of these inputs and outputs. So I usually start on the edges, and then I work my way in, making sure that as I build my block diagram, I have all the pieces necessary to actually do the thing. So let's take an example here. So if I grab a web display, and I throw it in here, I know I'm going to need something like this in order to create a user output. Now, notice I'm not saying what's in the web display. I'm not saying it's PHP written. I'm not saying it's a Python. I'm not saying it's JavaScript. I'm not saying that it's a custom design web page. There are a lot of tools out there now available. SparkFun has some great tools as well, for example, that allow you to interface your systems to a server that takes care of a lot of the data work for you. So that's a possibility. But I do know it needs a web display. Okay. Now, if I'm going to connect these two, which is what I'm showing here, it's no longer system to outside. It is now web display to outside user output. So that's changing this output so that it's obvious where the data is exactly coming from, where the information is exactly coming from. Another one I might run into is I might add an enclosure. So for the enclosure, this is probably the best way to deal with, so to speak, the water situation. So now we have outside to enclosure for that input. Okay, so the idea here is that the water, 3 inches of rain per hour, hits the enclosure and doesn't affect the rest of the system. It stops at the enclosure. So I won't have to draw this line connecting to multiple locations. Another thing I know I have coming in is the solar power. So since we talked about this in the last video, we decided that our system, the solar power, is our responsibility. So we have to choose the panel. Therefore, the panel itself is going to be included as part of this. Now, why did I call it solar panel? In the web display, I mentioned that we don't describe the details of what's in the block in the name of the block, but in this situation, I'm actually saying solar panel. The reason being there's really no other way of gaining solar energy except for using a panel. So I think I can make the assumption that that will be the solution, and I can actually put it in the name of the block. Finally, we can add the depth and temperature sensing. So again, notice that I didn't specify what is the depth and the temperature sensing medium. I could use ultrasound, I could use LiDAR possibly, I could use a thermistor, I could use a thermocouple, I could use a variety of tools to actually accomplish this. I'm not encoding those tools within the name of the block itself. Okay, let's go ahead and update these names to make sure that they make sense in the future. And I'm going to shorten this one because it is incredibly long to just sensing. So now I have a set of blocks dealing with my inputs and a block dealing with my output. And somewhere in between those, I have to glue them together and make sure that the information coming in produces the information out that I expect. Based upon what I'm seeing, I'm going to use my engineering expertise. I'm going to create some blocks. These blocks might change. Your block diagram is a living document. The version you first turn into us or show us may or may not be the version that exists at the end, and that's fine and expected. But so for example, I think we'll probably need some way of charging, because if we're going to be running and we don't have the sun all the time, we're probably going to have some type of way of saving that energy. I think we're probably going to have some type of a power supply, because if we have the ability to charge, that's great, but odds are that we're going to need some assortment of voltages that are not part of charging the battery. So add a charging and a power supply. And notice I'm visually clustering those near the solar panel so that I kind of have a way that when I look at it, I see what's related to what. It also avoids a lot of extra interface wires going every which way across the design. Looking at the output, the web display, I know a little more maybe than some people would, and I'm going to actually include a server block. So what the server block does is it's what actually grabs the data and holds onto it, while the web display is the block that actually is going to display the information to the user. So kind of a two-step process there. My guess is that I'm probably going to need some type of processing. I'm going to need some way of taking the data that's coming in and doing a little bit of math on it, doing a little bit of work on it, somehow smoothing it out, making sure it's good data, and then actually eventually sending it on to the server, into the network, which brings up a great point. So we definitely need a block that allows us to actually communicate with the network. So in this case, we're calling it network communications. Even though I said in the description this is a cellular system, because I know that from the beginning, I'm still leaving this as a nebulous network connection, because it is possible that I might want to do something different as the system evolves, maybe LoRa or some other technology. And then finally, we need to have a code block. So there is a server code block as displayed here, but this code block is for the processing, whatever it is. It's really important that you actually split these into two pieces, processing and code, because by doing that, it allows you to split the work among two people. Now, arguably, the person doing the processing block is probably going to be the person doing the code block, but there is an opportunity to have that split or at least shared responsibility if you break it out now. Okay, let's go ahead and drag this back block out of the way just to make it a little cleaner and easier to see. Now what we need to do is go about actually interconnecting these in an intelligent fashion. These lines are going to represent interfaces, and these interfaces are what are used to identify who has to communicate when a change is made. So for example, if I add an interface that's between the depth sensing and the processing block, there's going to be some properties we're going to talk about in interface definitions of this signal. And these properties are going to change as the system evolves. You're going to realize, oh, I have to have 3.3 volts, or oh, I have to have 5 volts, or oh, I have to have something different, whatever it might be. And in the situation of this interface between depth and temperature sensing and processing, there's really only two people that need to communicate. The person that's in charge of the depth and temperature sensing, and the person that's in charge of processing. That's it. Now, arguably with a group of 3, you guys will probably all talk it out, but if you were in a much larger group, the only two people involved in the conversation have to be those two individuals. Now, of course, they could be the same individual as well, and then they just have a conversation with themselves. So let's go ahead and we'll put a label on this because it's important to have a name on things. Again, using our format that we've done before, the source to the destination. Okay, and what type is this? So this is something that's going to also evolve. It may or may not be this type. We're going to assume it's some type of an analog signal rather than like a digital signal. So it's probably going to be a voltage that varies up and down. We're going to make that assumption. Now again, that might change as we decide what goes inside of this system, and then that would naturally make an impact on what the processing system has to be able to deal with. Okay. Now this diagram here is a little tightly packed. You should definitely use a full page. I'm keeping it tight so that it's more obvious in the video. But definitely spread this diagram out when you're normally doing it. All right, I'm going to go ahead and continue making all the interface connections and labeling them, and then I'll see you in the next video.